Okay, so section 2.5, we focus on problem solving with formulas. And the formulas that we have in front of you that are on the top of the notes are formulas that we should get to know. Okay, now for this test, I will give you the formulas for this test, but eventually formulas like distance, rate, time, area, length, width, perimeter, 2 length plus 2 width. We're going to need to know them. So I want to encourage you to learn them. But when we're looking at these formulas, we're going to be using them in the word problems today. Okay, so we're going to refer back to that page 1. Now we're going to use the same steps that we had talked about last Tuesday. Remember, we looked at number 1, we have to understand the problem, right? Understand. We have to know what we're looking for before we know what, how to find it. Okay, so what are we looking for? Translate. Translate means to put the words from the word problem into an equation. And then solve. We're going to take the equation that we have, use our order of operations, then the properties of equality that we have to solve, get an answer, and then interpret. And with interpret, we're going to express our answer and then do a quick mental check. Okay? So with this, we're going to do all of these steps today without a calculator. And students have asked me, so why don't you want a calculator on the tests? And it's actually a math department policy. So I would prefer you didn't have a calculator on this test because there won't be a calculator on the next test. Okay? But we can talk about it. So example 1, a glacier is a giant mass of rocks and ice that flows downhill like a river, a very slow river. Portage Glacier in Alaska is about 6 miles or 31,680 feet long and moves 400 feet per year. Icebergs are created when the front end of the glacier flows into Portage Lake. How long does it take for the ice at the head or the beginning of the glacier to reach the lake? So my first thing I'm looking for is, what am I looking for? And if I read that last sentence, it often describes what we're looking for. It says, how long? All right, so when we're describing how long, often we will describe it for time, because how long does it take for the ice at the head, the beginning of the glacier to reach the lake? That means the time. And so the time specifically is equal to the time for the ice to reach the lake. Now, another thing that I notice in this problem is that we're looking for time, but we are given a distance, 6 miles or 31,680 feet, and we are given a rate, 400 feet per year. So the formula that I'm going to use, because it deals with distance, rate, and time, is distance equals rate times time. And you'll find that in the chart at the beginning of our notes. So I know the distance. The distance is either 6 miles or 31,680 feet. Now, we have 2 options for our distance. One is in terms of miles, and the other one is in terms of feet. And we need to know which one will we use. Well, what I do notice also, as far as the rate, this 400 feet per year, that is in terms of feet. And so I will use the feet, the 31,680 feet, because we need to be consistent in the units that we use. And in this case, it's feet. So entering, I know that our distance is equal to 31,680 feet. And I know our rate is equal to 400 feet per year. So I'm going to enter this information into my formula. So my distance, 31,680 feet is equal to my rate, which is 400 feet per year, times my time. Now to solve for this, what I'm going to do, notice I left my units in, and you can choose to either leave your units in or take them out. But I'm going to go ahead and divide both sides by the 400 feet per year. Notice the 400 feet per year cancel off of the right, and I'm left with a T. And on the left, well, we have to do some long division, all right? So let's go ahead and do the long division, and I'll do that off to the side. So I have 31,680 feet, and I'm going to divide it by 400. So 400 doesn't go into 316, but it does go into 3168 or 3,168, a total of 7 times. It's hard to read that, I'm sorry. I'm going to subtract, and I get 368 when I look at the difference. I'm going to bring down the 0, and I notice that 400 now goes into 3,680 9 times. 9 times 400 is 3,600. Subtract, and I get 80. So I'm going to add a 0.0. We're going to bring in the decimals. So bring up that point there. Bring down the 0. 400 goes into 800 2 times. 2 times 400 is 800, and that's my 0. All right, so through the long division, we know that our time is 79.2 years. All right, so with that, we interpret. And interpreting means you're going to express your answer in a sentence. If it's a word problem, we express it in a sentence. So the question was, how long does it take for the ice at the head or beginning of the glacier to reach the lake? We can write, it takes the ice 79.2 years to reach the lake. And that is our answer. Any questions? No? All right. Let's take a look at the next question. Okay. Now remember that we can use charts, we can use pictures, anything to help us solve these equations. So reading this next equation, or sorry, word problem, calculating the length of a garden. Charles Picot can afford enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of his garden must be 30 feet, find the length. All right, so we need to understand this. And so it looks like Charles can afford enough fencing to enclose a rectangular garden. Okay, so here's my rectangular garden with a perimeter of 140 feet. So a couple of things that I know that for perimeter, the formula is 2 twice times the length plus twice times the width. Perimeter is the distance around the garden. In this case, it would be the garden fencing. Another thing I know just from that first sentence is that he has enough fencing to fence 140 feet. All right, now the last sentence says, if the width of his garden must be 30 feet, find the length. So here's the length, and we know the width of the garden has to be 30 feet. So I have enough information to replace the variables in my formula to solve. We need to put enough information, fill in, really, it's like all but one variable. okay, to be able to solve. So to translate this, I'm going to read and just go through my formula. Perimeter, which is 140 feet, is equal to twice times the length. Well, we're trying to find the length. Okay, this is what we're trying to find, is the length, plus 2 times the width, which it states is 30 feet. And there's our formula. There's our equation. So the first thing I'm going to do is take care of the multiplication of the 2 times the 30. And I get a 60. Then, using the properties of equality, in this case, I'm going to subtract 60 from both sides. Notice the 60 cancels off the right, and I have 80 is equal to 2L. And then using the division property of equality to get the variable completely alone, I have to divide by the 2. And notice when I divide by that 2, it cancels off to the left. And I have 80 divided by 2 is 40, is my length. All right, so let's go ahead and check this one. This is a nice one to check. So what I want to make sure is to see is 140, is that equal to twice times my 40 plus twice times my width of a 30. All right, so 140, I don't know what just happened. Oh, there we go. I don't know what just happened. Here we go. I pushed a button, sorry. So 140, is that equal to 80 plus 60? And the answer is yes, it is. So to interpret just means to express our answer. We're supposed to find the length of the garden, and we would just write the length of the garden is 40, and then you must add units, 40. Finding an equivalent temperature. The average minimum temperature for July in Shanghai, China is 77 degrees Fahrenheit. Find the equivalent temperature in degrees Celsius. All right, so we do have a formula, so I'm going to scan up to the top of the page, look at my chart, and I notice that we do have these degrees Fahrenheit to degrees Celsius formulas. Now, when I look at what we have on the left under the list of formulas, we can either look at this, the example that has the fraction, or we can look at the example that has the decimal. And for our time together today, I'm going to look and use the formula that has the fraction. Fractions, I'm hoping something will cancel, and then the numbers that we have will be smaller and easy to multiply. So I'm going to bring this formula down. Fahrenheit equals 9/5 C plus 32. Okay, so I'm going to scroll back down. So I'm going to write that first so I don't forget. Fahrenheit equals 9/5 C plus 32. All right, so reading it one more time. The average minimum temperature in Shanghai, China is 77 degrees Fahrenheit. Find the equivalent temperature in degrees Celsius. All right, so we have this formula. We want to find Celsius, which is our C, and we're given F, which is 77 degrees Fahrenheit. So we're going to put the information we know into that formula. Using this, the formula that we have, 77 is equal to 9/5 times Celsius plus 32. Now we can solve using the properties of equality. So the first thing I'm going to do is to subtract 32 from both sides. I end up with a 45 on the left is equal to 9/5 C, and I notice that the 32's cancel on the right. All right, now I need to solve this. Now, one property that we have is the division property, and we can divide by 9/5, totally fine. But an easier way to solve this equation is to use the reciprocal. multiply both sides by the reciprocal. Now, the reciprocal of 9/5 is 5/9. And a wonderful thing about reciprocals is when we multiply reciprocals, notice we get all this canceling and it equals 1. So when you multiply reciprocals, it equals 1. So we're going to multiply both sides by this reciprocal 5/9. And we'll say 5/9 times 45 is equal to 5/9 times 9/5 C. Okay, on the right, I notice that we can do some canceling because we're multiplying fractions. We have a common factor of 5 on the top and the bottom. 5 goes into 5 once in both cases. And we have a common factor of 9 in the bottom and on the top. 9 goes into 9 once in both cases. So on the right, we are left with a C. Okay, so that worked out really nice to multiply by the reciprocal. Now, when we're talking about the left, I like writing my numbers, my whole numbers, like 45. I like writing them over a 1 when I'm multiplying by a fraction, because it shows me how I can cross cancel. Because I do notice here that 9 goes into 9 once and it goes into 45 5 times. And then the denominator, we just have a 1 times a 1. Leaves us a denominator of 1. And 5 times 5 is 25. Okay. In fact, we could say it's 25 degrees because that's our C. But I'm going to save that for interpret. When I interpret, it says find the equivalent temperature in degrees Celsius. The temperature is 25 degrees Celsius, or you can just write C.
I have a question.
Yes.
So I did it a little bit differently.
Okay.
So when you get down to the where it's 45 and then the 9/5 C,
Yep.
what I did was I multiplied like the right side, the 9/5 C, I just multiplied that by 5 and I did the same to the other side.
Yep.
And then after that I had 9C on one side, and then I did and then I had 225. And so then I divided by 9 on both sides, and then I got the same answer. Is that correct or no?
Totally correct. And I'm going to tell you why, okay? I'm going to tell you why. That is excellent. Sorry, I'm just sliding around here. So the reason that that works is this. I'm going to use this information down here, okay? So this is my scratch paper. And I appreciate you bringing that up. And so I'm going to give you a visual first to what Boryette said. All right, I'm going to take this, make sure I get the right information. So, and this is totally okay to do all the time. So we have that 45 is equal to 9/5 C. So what Boryette did is he said he multiplied first to get rid of this denominator. He multiplied both sides by a 5. All right, so notice that the 5's cancel on the right. And he was left with 9C. Perfect. On the right, and on the left, it was 225. Awesome. Then, to take care of the 9C, we use the division property of equality. We do the opposite. The opposite of multiplying is dividing. On the right, the 9's canceled, and we're left with this C. And on the left, 9 goes into, well, if we look at it, it'll end up being 225 25 times. All right, so Boryette, that's what you were talking about, correct?
Yeah, I found that like a lot easier than the other way.
Totally. Now, the reason that you can do it, and I agree, I think students can see it either way. This is a wonderful way to do this, totally wonderful way. Now, the reason we can do it is that when we look at 9/5, we're actually multiplying by 9 and dividing by 5. So you got rid of the 5 first in the denominator. So the opposite of dividing is that multiplying. And then you get rid of the 9, you divide it. So it's that total combination. And I do want you to see we got the exact same answer. We got the exact same answer. So you can use, for the whole class, you can use either way. Borjet's way is 2 steps, exact same answer, no guesswork, right? My way is 1 step, but you have to remember what reciprocals do and what the canceling is. Both of them are equally efficient. Thank you for sharing. I appreciate that.
Yeah, no problem.
All right, other questions? All right, well, let's take a look at the next example. All right, so here we are going on, and it's finding the dimensions of a rectangle. The length of a rectangle is 1 more meter than 4 times its width. Find the dimensions if the perimeter is 52 meters. All right, so we want to find the dimensions. And when we're talking about dimensions, we're going to find the length, and we need to find the width of our rectangle. Okay, so I'm going to draw up our rectangle again. And I'm going to label what we have. So usually with a rectangle, right, we always have a length and a width. The length of a rectangle is 1 more than 4 times its width. Okay, so here's the length, and it's going to be 1 more than 4 times its width. Now you can write 1 plus 4w because addition is commutative, but it's 4w plus 1 would be the more typical way to write this. Another bit of information, when it says to give or find the dimensions, excuse me, dropped my pen, is that it tells us that the perimeter is 52 meters. All right, well, we know that perimeter is equal to twice the length plus twice the width. All right, we need to make sure that we enter the information into our formula, so we only have 1 variable. So to translate this, for perimeter, I'm going to put the 52 for meters. And for length, instead of adding the L, I'm going to use it in W form, right? The 4W plus 1. So 2 times 4W plus 1. And then we have our width as 2W. And the next thing we need to do is to solve. So I notice that I have a little simplification that I have to do on the right. So we'll have 52 equal to 8W plus 2. And what I did is I distributed, right? I used the distributive property, and I multiplied the 2 times the 4 for 8W and the 2 times the 1. So I cleared parentheses that way, but now forget that 2W at the end. I'm now going to continue to simplify the right and combine like terms. So 8W plus 2 more W's gives me 10W. Bring that 2 along. Right, and now both sides of the equation are in simplest form. My next step is to use the properties of equality to get W alone. So I'm going to subtract 2, because I'm going to do the opposite of plus 2 to move my constants to the left. The 2's cancel on the right. I have 50 equals 10W. And then I'll use the property of division, or the division property of equality, to divide by 10. Notice the 10's cancel on the right, and I have W is equal to 5. All right, now if W is equal to 5, I know that length is equal to 4 times W, or 4 times 5 plus 1, and my length will be 21. So remember, when you find the value for one variable, we need to take that in, right? and plug it in so that we can find the value of the other variable. So the dimensions of the rectangle are width equal to 5 meters and a length equal to 21 meters. Any questions? All right. If there are no questions, we're going to continue. Now, the last part is something that we call, it's called solving equations for a specific variable. In math, it's called solving a literal equation, same thing. But what you'll notice for these 3 examples that we have is that there are no numbers, right? So what we're going to do is we want to use our properties of equality, the addition, the subtraction, the multiplication, and the division properties of equality to get a specific variable alone. All right, now, with the first example, and then we'll read the instructions, it'll be presented like, solve for the specified variable as the instructions say. And then you'll be given an equation or you'll be given a formula. Now this is C is equal to 2 pi r. Now that C would be for circumference because I know the formula for circumference. And they want us to specifically solve this equation for r. Now we'll read through the properties right now, and then let's take a look at this equation and solve it for r. So the first thing we're going to do is we're going to multiply both sides of the equation to clear any fractions or decimals if they occur. Now that's the exact same first property that we did for solving equations, right? That's the same first step. Number 2, use the distributive property to remove parentheses if they occur. And if you look back, that is the second step that we have for solving equations as well. 3, simplify each side of the equation by combining like terms. Again, it's the same step that we had before. 4, we're going to get all of the terms containing a specified variable on one side and all of the other terms on the other side. Okay, and that would be using the addition or the subtraction property. And finally, get the specified variable alone by using the multiplication or the division property of equality. So these steps actually are the steps that we use to solving equations, but we're just doing it in an equation that has very few or no numbers. Okay? So when I look at an equation like the first one, and it's again, C is equal to 2 times pi times r, I'm going to rewrite it just a little bit bigger. And I'm going to underline the variable for which I am solving. Now, the only reason I do that is to draw my attention to it. Because I need to, first multiply to get rid of decimals and fractions. I don't have any of those here. Distribute to remove any parentheses, no parentheses here. Simplify each side. Each side is the most simplest form. But then it's like getting all the terms by using the addition or subtraction property on both sides, right? Well, we don't have to do that either. The last step is using the multiplication property or the division property of equality to get this r alone. That is where we have to start. So what I'm going to do is I'm going to leave this r, but I'm going to divide by everything else. So I'm going to take the left or the right side and I'm going to divide by 2 pi, which means on the right side we divide by 2 pi. On the left side we also divide by 2 pi. Now I'm going to notice it cancel on the right. I'm left with an r. R is equal to C divided by 2 pi. And you could write it this way, R is equal to C circumference divided by 2 pi. That would be our answer. So when it says to solve an equation for a specified variable, and they give you the variable, right? We're just going to get that variable alone. So let's take a look at 2. So with number 2, we're given the equation y is equal to 3x minus 7. And we're asked to solve this for x. All right, so I'm going to rewrite it so I give myself just a little bit more room. And since we're solving for x, I'm just going to underline that to draw my attention to that x. And I can go through the steps, but I have no decimals, no fractions, and no parentheses. So step 4 says to use the addition property to get the variable terms that we're trying to solve for on one side and all of the other terms on the other. So since we're trying to solve for this x, I'm going to keep this 3x on one side, and I'm going to move that minus 7. And I'm going to move it by adding 7 to both sides. All right, so what remains is y plus 7 is equal to 3x. Now notice that my x term, all right, my x term is alone. All right, and that's a good thing because I want to get that x completely alone by itself on one side. So that was a great step. Now finally, to get x completely alone, we're going to go to step 5. And step 5 says to divide both sides, right? And this time we're going to divide by 3. Cancel that 3 off of the right. And so my final answer would be x is equal to y plus 7 divided by 3. Now I do want to let you know, my math lab may ask you to answer things a little differently. And I want to show you why they're going to get their answers. So we'll start with this x is equal to y plus 7 divided by 3. Now, that 3, what that means is I am dividing every single term in the numerator by 3. Okay? So I can write this x is equal to y divided by 3 plus 7 divided by 3. That would be my next step. And that is the fine equation as well. One more step that you may see is instead of saying y divided by 3, we can say 1/3 y plus 7/3. Now, this 1/3 y, because when you divide something by 3, you're really looking for 1/3 of it. Right? When you divide it by 3, you're looking for 1/3. And any of these 3 equations are acceptable. But I want you to just pay attention to what they're saying in my math lab, because they may ask for this form, or they may ask for 1/3 y plus 7/3. Or just so you know that you could be asked for different forms. Do you have any questions over number 1 or number 2? Okay, let's take a look at the next example. Number 3. All right, so we had P is equal to 2A plus B minus C, and we want to solve it for A. So I'm going to go ahead and say, okay, P is equal to 2A minus B, plus B minus C, and I'm going to underline that A just so that I remember what I'm solving for. So in my first step, I'm going to subtract B, and I'm going to add C to both sides. Now, when I do that, I'm going to subtract B and I'm going to add C. So notice that the B's cancel and the C's would cancel. If you rewrite everything, we have P minus B plus C is equal to 2A. All right, so that's a great first step. So we got rid of 2 of the terms, B and minus C. We got rid of those 2 terms in one step. All right, now to get A completely alone, because there isn't any other simplifying that we need to do, I'm going to underline that A, and that's what I want to remain alone on that side. I'm going to divide both sides by the coefficient, that 2. Divide by 2. The 2's cancel off the right, and we will have P minus B plus C, all of it over 2. Now you have to have that division line or that fraction line under the whole thing is equal to A. Or we can write with the A on the left, A is equal to P minus B plus C divided by 2. Okay. Now one more word